RL. So you can, this is an usual practice. Whenever we find output resistance, we find one more output resistance called R naught F dash, considering your RL. And this standard formula R naught F dash equal to R naught F parallel to RL. R naught F formula, R naught by 1 plus beta RM parallel to RL. So when resistance are parallel, we'll apply the formula R1 R2 by R1 plus R2. Okay, so apply that formula and simplify. Again, I say the simplification. See, all these are constants. It is just you have to bring it to some proper format. Okay, so you have, after substituting the parallel resistance formula, you will get R naught RL by R naught plus RL plus beta into RM into RL. So I'm dividing the numerator and denominator by R naught plus RL. See, this R naught plus RL is separately lying here, right? So I'm dividing that with the numerator and denominator. The numerator you see R naught RL by R naught plus RL divided by denominator. The first term is 1 because it is divided by the same term. So the first term is going to be 1. This term is 1 plus beta into RM RL by R naught plus RL. So I'm replacing R naught RL by this term as R naught dash. And already RM into RL by R naught plus RL is R capital M. Okay, so already we know about R capital M. Just this term I'm replacing it by R naught dash. So finally I will get R naught dash equal to R naught dash by 1 plus beta into Rm. So if R naught F is reducing, R naught F dash will also reduce because it is going considering your R naught F, right? So if I draw a diagram, R naught F will be found here and R naught F dash will be found here, considering RL. So when you include RL, you call it as R naught F dash. When you don't include RL, it is going to be R naught F. These concepts you should not forget when we see application. When you find R naught F and R naught F dash, this will be very, very helpful. You will be disconnecting RL and find R naught F, and you'll be connecting RL and you'll be finding R naught F dash. So at that time, if you don't recollect all these concepts, it's going to be very, very difficult for you. And already we have told that RM is without considering load, and now R suffix capital M is considered load resistance into account. So R naught F dash and R naught F will be finding for all amplifiers. Output resistance will be finding two variation, R naught F and R naught F dash. R naught F is excluding your load, which you are going to connect externally, and R naught F dash is including your load. Okay, so that is the difference. And always this formula will hold good. R naught F dash equal to R naught F parallel to RL. Because till this point you have R naught F, and across R naught F I'm connecting RL, so it is R naught F parallel to RL. Whatever value of R naught F you get, do a parallel formula with RL, that is going to be the value for R naught F dash. See, in practical application of problems, we will not be using all these big expressions. It is just derived for your theory portion. Practical examples, we will be directly substituting the value and we'll be finding the value of R naught F and R naught F dash directly. Don't think you have to remember all these big formulas for solving problems. No. Whenever a theory question comes, that too you are going to derive this. So you need not by heart anything, or you need not remember how the expression will look like, because it is already very big. So it is not a good expression to remember and write in exams. Okay, so as long as a theory question comes, you can derive this expression on your own. If you apply KVL, KCL, and if you simplify terms, you divide, multiply, take out common terms, you're definitely going to get this expression. When problem comes, you will be directly substituting the problem and you will not substituting all these theoretical formulas.